Okay, so the last couple problems we're going to look at are going to have what are called multiple angles. So I'm just going to make a little note here that we're talking about multiple angles. And what that looks like on a problem is something like this. So say I have 2 times the cosine of, and not just t, but 3t minus 1 equals 0. We're going to solve it the same way we would as if that was just a plain old t or x or theta. So I'm going to add the 1 to the other side, and then I'm going to divide by 2. I'm still going to isolate the cosine of 3t. So the cosine of 3t equals 1/2. Now the angle we're looking for is 3t. Once we find the angle, we're going to have to do one last step to figure out what t is, because 3 times t is the angle. So on our unit circle, our cosine values, our x values, are 1/2 at pi over 3 and 5 pi over 3. And so I have two solutions here, but they're not equivalent to t. They're equivalent to 3t. So what we need to do is we need to multiply by the reciprocal of 3, or divide by 3 if you want. But I think it's easier to think of this as multiplying by 1/3 because we have fractions over here that we're going to deal with. So when I do this, I'm going to go ahead and say, all right, well, the 1/3 and the 3 cancel out, so t equals. And then 1/3 times pi over 3, we just multiply. Pi times 1 is pi. 3 times 3 is 9. For the 5 pi over 3, same thing. 5 pi times 1 is 5 pi. 3 times 3 is 9. And these are our angles. So yeah, the only little wrinkle here is that once we figure out what our angles are, we still have to do some math operation to isolate the variable. In this case, it was t. So let's look at another example. And let's say we have sine of, and instead of a whole number, let's say we had a fraction, 1/2 x minus root 2 over 2 equals 0. So we're going to do the same thing. We're going to isolate the trig ratio here, so the sine of 1/2 x. So I'm just going to go ahead and add the root 2 over 2 over. And so we have sine of 1/2 x equals root 2 over 2. Okay, so we're not going to do anything with that 1/2 right now. We're just going to think of it for the moment like theta, or some angle that we don't know. And we're going to say, all right, what angles have a sine value of root 2 over 2? So sine is y, and that's a positive number. So we're looking in our first two quadrants. So our angle, which is 1/2 x, equals the pi over 4 angles from the top two quadrants. So pi over 4 and 3 pi over 4. Now here I've got 1/2 times x. The way we get rid of that is by multiplying both sides by the reciprocal, in this case, 2. So I'm going to multiply both of these by 2. That's going to cancel this out, so we just are starting to solve for x finally. And when I multiply times 2, I get 2 pi over 4 and 6 pi over 4. Now if you look at those, we could reduce those. We could write those more simply. And we would get pi over 2 and 3 pi over 2. And those are our angles. So just keep in mind here, when we have the multiple angles, there's just one last step once you find your angles of isolating the variable that's within the angle. All right, let's look at one last example. All right, so if I have 3 times the tangent of 3/2 x plus 3 equals 0. All right, just like we did in all the other problems, we're going to isolate the tangent and the angle. So first things first, minus the 3. Okay. And then this 3 in front of the tangent's in the way, so we're going to divide by 3 on both sides. And so I get, here we go, I get tangent of 3 over 2x equals 3 divided by 3 is 1. All right, so we're going to figure out our angles where tangent is 1. Keeping in mind tangent is y divided by x, and in order for those to be positive 1, we need y and x to match exactly. And that happens at pi over 4, where x and y are both root 2 over 2, and at 5 pi over 4, where x and y are both negative root 2 over 2. All right, so that is what 3/2 of x equals. We still want to know what exactly x equals. So to get rid of that 3/2, you could divide by 3/2, or 1.5, but the easier way to think about it mathematically is, all right, let's multiply by the reciprocal. So I'm going to say, all right, 2/3 times both of these. So here on the left, that just cancels out the 3/2, and we get x equals. And then I'll go ahead and distribute. So I have 2 pi when I distribute the 2 into the first one. And then on the denominator, 4 times 3 is 12. Then we do the 5 pi over 4. So 5 pi times 2 is 10 pi. And 4 times 3 is 12. And then just take a quick look. Can you reduce those? If you can, you need to go ahead and do that. Pi over 6 is the first one. And then the second one reduces to 5 pi over 6. And that's it. All right, so go ahead and tackle that homework assignment now.